Hello everyone, welcome back. Are you yearning to add HMI to your Arduino OpenPLC projects? Doing this, you will be able to monitor in real time what the system is doing. In this video, I will share with you how I controlled an Arduino board wired with a relay model from an HMI interface designed with ScadaBR. Let's get started. Kindly subscribe if you've not done that already, and also press on the notification bell. This way you always be notified whenever I upload new video. Okay, so now let's look at the hardware we will need for this project. We will need an Arduino Nano. If you're having an Uno, you can also use that. We will need a relay model. And now let's look at the circuit. We have the 5 volts connected to 5 volts of the Nano, and then the ground connected to ground. And then we have the pin 7, pin 8, and then pin 2 connected to relay 1, 2, and 3 respectively. And then we have 5 volts connected to the 5 volts of the relay model board, and then the ground also to ground. Okay, now let's look at our hardware wiring quickly. We have white connected to negative, yellow connected to positive 5 volts, and then we have the rest of the cable connected to relay 1, 2, 3. Okay, good. And we have our Nano there that we need to program. Now let's look at the software that we will need for this project. For programming the Arduino logics, we will need the OpenPLC editor, and then for the visualization, that is the creating of the graphics, and then the HMI design, we will need the ScadaBR. I guess we already have the OpenPLC editor. And now to install the ScadaBR, you go to the ScadaBR website, and then you scroll to the bottom of this website, and then you have this download link. Click on it. Okay, then it will give you this section where you have the version of the OpenBR software. So you scroll to the bottom, and we are doing the installation for Windows, so we click on Windows to start the download, and we can see the download has started. Okay, so the next software that will aid you install the ScadaBR is Java 8. So you go to the Java website, and then you scroll to the Windows. I'm doing it for Windows. I select Windows, and then I click on the offline download to start the download. Right, so right now we have the two software downloaded. The first one we need to install is the Java. So I right click on it and then run as administrator. I say yes. Click on install. Okay, so with the Java installation completed, we can now run the ScadaBR. So I right click on it and then run as administrator. I say yes. Okay, move to next. I agree with the terms and condition, and I say next. I click on next. Now we can see that ScadaBR is requesting for the part where Java 8 is installed. So you click on browse, program files, and then we go to Java, select it, and then you said okay, and then next. Port will be port 8080. If you are having OpenPLC runtime running, it will conflict with this, but for now I don't have OpenPLC runtime running on this machine, so I can leave it at 8080. If you do, you need to change the port number. Okay, so with this done, you can leave this place blank, and then you click on next, next again, and then wait until it finishes installing. Okay, so installation is done. You click on finish, and then now we can check to see whether we have the ScadaBR in service manager. So I can click on it. I say yes, and then we can see that everything has installed correctly. So I click on OK. Alright, good. So after the installation, you need to check if everything is working fine by typing localhost port 8080, but my 8080 was having conflict, so I changed it to 8081, and then I click on enter. And if you have this interface indicating that everything is working fine. Okay, the next is to access the interface of the ScadaBR. So you see /ScadaBR, and then you need to observe how you type the ScadaBR. It's first letter capital and then the BR also capital. If you miss this, it's not going to open. Okay, so now we have our ScadaBR installed. Now let's move on to OpenPLC editor, write our logic, download it into the PLC, that is the Arduino board, and then we come back to ScadaBR to do our design. Okay, alright, so in OpenPLC I've created a project called Arduino 4 relay and then created the logics. Okay, so let me walk you through the logic quickly. So in this example, we are going to switch on 3 relays in sequence with a delay of 200 milliseconds. Okay, so first thing we need to do is to create our variable. So I have motor 1, motor 2 up to motor 3, and then we have our timers that is going to do the delay work for us. So 3 of the timers, so timer 0, 1 and 2. You can access the timers under the standard block, and then we have the time on delay timer, and then we have the off delay timer. In this case, I'm using the on delay timer. Okay, so we have our start push button that is going to timer 1, and then the output is turning our first relay on. Remember, our relay model is active low, so I need to invert the output signal. That's why I chose negated here. If I use the normal, which means it will be energized when I've not sent command, and when I send command it will de-energize, and I don't want it that way. Okay, good. Doing that, then I need to specify the delay time. So with that, you can also use clicking on the variable. You can then create the time delay, which is 200 milliseconds. Okay, great. So with our variable created, and then we'll look at the output that we assigned. Remember, the motors are output, so we have output 0.0, 0.1, 0, and then 0.2, which correspond with the wiring that we just did on the Arduino board. And then for the start command, remember, you can see I'm still using output 0.3, indicating that I'll be writing it through the Modbus, so it needs to be an output coil. Okay, good. Now the first thing we need to do is our start normally open contact that is connected to the input of our on delay timer, and then the output goes to the output relay that is labeled motor 1. Okay, then the next we use the same command. So immediately output relay 1 switches, it will then activate the next timer, which is T1, and then remember the output is also normally closed because the command has been inverted. Okay, then the output goes to motor 2, and then motor 2 contact also switches the next timer on, and then the output goes to motor 3. So this way we'll have a 200 milliseconds delay in all the relays picking one after the other. Okay, so with this understanding, let's simulate quickly and see whether if our logic is working fine. So I click on the simulate button to start the simulator. Okay, so simulator started, so I can put on the go to monitor. So I click on it. Okay, good. I'm in the monitoring zone. So now I can then activate my start push button. Let me force it through and let's see what happens. Okay, we can see our first timer counting, and then it comes on. The next timer start counting again. It comes on, and then the following one also counts and then comes on. Perfect. It's working just as we want. So we will now move on and then download this into an Arduino board. So I can now stop the simulator. I click on stop, and then I can turn this one off, which is the simulator interface, and then I have this. Now I'll click on the Arduino icon to compile for the Arduino board. Okay, so I have my Arduino interface here. So we need to select which board you are using. Although my board is Arduino Nano, but it's the bootloader is Uno, so I select Uno for my board. And if I want to do compilation only, but this one I want to activate the Modbus, so I have to specify my ports where the Arduino is connected to, and then activate Modbus as well. Baud rate is still the same, ID is 1, and then I leave everything as it is, and then I can click on the download to download it into the Arduino. Remember, if it's your first time, it will take some time, so you need to be patient. Remember, ScadaBR and then the Arduino board will be communicating via Modbus. That's why we needed to activate the Modbus interface, which is Modbus RTU. So when we go to ScadaBR and connect our Arduino, we need to then configure for it to accept Modbus data. With the downloading done, let's move to ScadaBR and then configure to connect to our board, and then we can design our HMI interface. Okay, so we have our ScadaBR interface. The username is admin, the password is also admin, and then you can click on login to log in. So we have our interface open now. Now the first thing we need to do is to establish connection between our Arduino board and then ScadaBR. And to do this, we need to use the data source. So we click on the data source icon. Okay, so we have our data source open now. Now we need to select which protocol we'll be using to communicate between the ScadaBR and then the Arduino board. So I drop this, and remember we chose Modbus serial, so we need to select Modbus serial, and then I can click on add to create a new data source. Okay, so now we have this interface that we need to configure. So we need to give it a name. We can say underscore, let's say relays, and then we need to specify our baud rate. Remember when we were downloading, the baud rate was 115200, so I select that. And then we need to identify which ports that the Arduino board is connected. When we're downloading, it was connected to board 21. You need to identify yours as well and then select it. Now the rest remain the same, and then is Modbus serial RTU, so we use the same thing. Then we come to the Modbus read data. Slave ID was 1, so we leave it as 1. Coils are also here, so we leave it as coils. And then remember, we don't have 100 coils, so I'll just set this one to, let's say, 10 coils. And then we can read to see whether we have connection between our board and then the ScadaBR. Okay, great. So we can see our coils now, and we call 0, 1 and 2. Remember, we inverted the output. They are now showing true, which indicates that we are really connected. So with this connection, I can click on the save button to save my configuration. Okay, we can now have this information indicating that data source has been saved. The next thing we need to do is to add points. So basically, data source is referring to where we are getting data from, which is from the Arduino. And then the point are the specific information we'll be reading from the data source. So I come to this point, and then I click on add points to add my points. Right. So we now need to add a point where we'll be reading the data from. So the first point will be the motor, which is our motor 1. Okay, the next thing that you need to change is the offset, that is the address. Currently that one is 0.0, so it will still leave it at 0. And then the data type is binary. Okay, so we leave it as such, and then we can click on save. Our first point is created. We add our next, which is motor 2. And then the offset address, remember, is 0.1, so we need to change this one to 1. And then we click on save. Okay, we add our next point, and then that is going to be our motor 3. So we say motor 3, and then the offset is 2, so we need to put 2. And then I click on save as well. And then our last point that we need to add is the start command. So this is going to be our start. And then the offset is on 3, so I put 3, and then I click on save. Great, so our points are all added now. Now to activate the points, I need to click on this icon, the status icon. When it turns green, indicating that it's verified and connected. Okay, so we have sources here. The next thing I need to do is to also connect the data source. So I click on this icon to enable it. It will blink for some time, and when it turns green, indicating that it's connected. Perfect. So we can see it connected. It is done now. Our configuration is done. We now need to move to the graphic interface to do our graphic design. So I scroll to the top, and then I click on graphics view to give us this interface, and then we need to give the graphic a name. So this can be our, let's say, Arduino drives. So we call it Arduino drives. And then I recommend you have a background, so you can choose your background that you've designed, either with paint or with any designing software, and then you it will form your basis for your background. For now, I've just designed one, just a black background with paint. So I will choose this particular background in my example. So I click on choose file, and then I navigate to the point where I've saved the file. So I have the HMI interface there. I click on open. Okay, so I have my background selected now. I can click on the upload to upload it. Great, so we have our background now. We can now add our tags or our design. Okay, so I select binary graphics, and then I click on the add. I click on display test, and then I choose specific image. So basically I needed a moto. Great, now I need to specify the states. Okay, so per our logic, when it's at logic 0, it means it's on, and then when it's at logic 1, it means it's off. So I select this 01 and I click on save. I need to specify which point I'm assigning to this, and this is moto 1. And I click on save. So we have our moto right here. I position it correctly, and then I go and add the next moto. So I click on next. In the same way, I click on this. I select the image settings, and then I choose moto, and then the same way 0 on, and then 1 means it's off, which will show blue color, and I click on save. And then I choose the info, the point I assign moto 2 to it, and I click on save. And then I add our third moto. I add our third moto, so I click on add again. Point, which is moto 3. I click on save. And then the graphics set, I choose the same moto. 0 means it's on, 1 means it's off. I choose this colors, and then I click on save. Also positioned, and then I'll add our push button. The push button I need to start the system with. So that one, the component type will change. It's going to be button right, and then I click on add. So I'll assign it to stats. I click on OK. Okay, it appears on. I come back here, and then I can change the graphics a bit. So on off, and then dimensions I can change it. The height I want it 40. The width I want it 100. I click on save, and then we can see that it has expanded a bit. Okay, so we have our design done, and then I'll add next component to just add a bit of beauty. So I'll go to binary graphics again, and then I click on add. So I'll assign the same moto points to it, which is moto 1. I click on OK, and then the graphic type, I can choose a fun. So when it's at logic 0, I have to choose the image, which is this 01, which is on, and then logic 1, I choose this image, which means logic 1, which is off, and then I click on OK. Great, we have our interface now. You can use the alignment tool to align if you want, but for now I think the arrangement is okay. So I can now go ahead and then click on the save button. So we have our system saved now. Okay, so I'll go back to edit mode and do some changes. I will change the first status to stop, and then the second status to start, and then I click on save. Okay, so note, in the configuration there's one thing you also need to change. That is the update rate. By default is 5 minutes, which is too long, so you need to set this one at 1 second. So I choose seconds and then change this one to 1, and then you can save again. Okay, so without doing this, your system will work fine, but you will get update very late. That's 5 minutes interval. Okay, our system is ready now, so we will test it quickly. I press on the start button and we can see the first motor has come on. Okay, second motor followed, and then we have the third motor. Great, which is working perfectly. I click on the stop, the system stops, and I press start again. Wow, perfect. Viewers, thank you for watching. See you in the next tutorial. Bye bye.